Hello, good afternoon, bachcho. How are you all? Yes, good afternoon. Welcome to India's largest एग्जाम प्रिपरेशन प्लेटफॉर्म इन्फिनिटी लर्न बाय श्री चैतन्य. मैं हूँ सुरेश अवारी, फैकल्टी ऑफ केमिस्ट्री. हाउ आर यू ऑल? हाय सत्येंद्र, RBS, good afternoon. Great, great. So many students I can see, those who studied in yesterday's class, good continuation, good. Ishita, hi. Who is that killer science? Good afternoon. Funny name. Praveen, hi. Very good. Hi, hi, hi. Good gathering. Good gathering. So how are you doing now? How the things around you around? Right? Skills? Great. Hi Praveen. Good, good. So today we are going to discuss about electrochemistry. Electrochemistry is a very important topic and we are going to discuss many subtopics in that. And उसमें importance क्या? There are two things we can say about the importance of the electrochemistry here. Anything you study from surroundings and our regular life. And second thing, you can learn it from your examination point of view. Hi, Jawat. Yes, RBS, what is electrochemistry? आप बताना पहले चैट बॉक्स में. हाँ. First of all, thank you very much for attending yesterday's class and continuing today's class. And I simply say, yesterday's class, it was awesome interaction between you and me and really enjoyed. And you also enjoyed along with us together. And please do share this session with your friends. And current class, you share and like and subscribe Infinity Learn channel. In the description box, it is given a Telegram channel also, the Telegram link also, you can join in that so that you will be getting updates on it, right? Right, okay. Satyendra, hi, hi, hi. Right. Many students. Great, great, great. Now, what is electrochemistry? First, let us see how it is connected with us. Do you have any connection of electrochemistry with your regular life? Chart में फटाफट डालो. How do you connect it with electrochemistry in the regular life? Okay, good, RBS. My question is, how do we connect this electrochemistry with our regular life? Cell, very good. Now in the current class, all of you are attending the class by using your cell phone or your laptop or your tablet. This has a battery in it. The batteries are nothing but application of electrochemistry. You can simply enjoy the class if you take a current context and connect to the daily appliances around you. है ना बेटा? Right. Madhavat, hi. Phone battery और बैटरी किस चीज में इस्तेमाल करते हैं? बैटरीज आर टू टाइप्स ना. एक बार इस्तेमाल करो फेंक दो. ये प्राइमरी सेल्स है और इस्तेमाल करने के बाद बार बार चार्जिंग करके फिर भी इस्तेमाल कर सकते हैं ना. दैट इज सेकेंडरी से बेल. वेयर डू यू सी द सेकेंडरी सेल्स? You can use in the mobile phones, you can use in the laptops, and nowadays we are using the batteries in cameras and the drones, and the trending is EVs, electronic vehicles, Tesla, Tata Neon, many are coming, right? This is about battery. Apart from battery, anywhere you are connected? Come on, put in the chat box. It's a live session here. Be interactive here. Come on. Emoji fire dalo if you are able to hear me and see me properly. Children, come on, fiery emojis dalna yaar. Hit like, comment, you give rain of comments. Which don't recharge are primary and which are rechargeable secondary. Jagan, your interpretation is correct. Great, great, great. Batteries are two types. One is a primary battery and the second one is a secondary battery. Primary battery is just use it and throw it. It can't be recharged. Secondary battery are you just use it, after you can recharge it, right? Primary battery cannot be recharged. Definitely, definitely primary charge, use it only for once. Okay, istemal karo, फेंक दो बस. That is used in a torch light and all, right? And remote controls and wall clocks, we use primary batteries. Okay, और क्या? चलो शुरू करेंगे आज का क्लास. My question is not completed. Apart from batteries, how you are connected with the electrochemistry and other regular life activities? Tell me. Hi. Sheshu. How we are again connected? Bike batteries, yeah, batteries, yes, we know it. And apart from batteries, how you are connected with the electrochemistry in regular life? Hello, R3 scale, sir, different names are given. In the chat box, I have been given this Telegram Infinity channel. Okay, you please enroll in that so that regular updates you are going to get. And please don't forget to share, like this session. Okay, bring your friends also to this session. So this session NEET STEP UP 2025 session, and this session is basically meant for those students who are already written NEET 2024 and planning for writing NEET 2025 seriously, and the sessions also applicable for those who completed 11th standard and stepping into 12th standard. They are also writing NEET 2025, and these sessions are live. Everyday session will be there. A topic wise total 11th and 12th syllabus will be covered for all subjects, right? Okay, now the study physical properties of chemical properties, yes, definitely. And be regular in the class and be interactive in the class so that we can make the class so excellent. And these YouTube sessions that we are providing from Infinity Learn are absolutely free. And you feel it is a free, na? So you may feel it is attending regularly or irregularly, but these sessions are definitely helpful for cracking NEET examination in 2025. We can assure you that. Not only you become a rank holder and topper bhi ban sakte. And yes, Jagan Naik, not daily teaching schedule, we chapter is going, and after conclusion the chapter is going to begin. Yeah, definitely I agree with you. Yesterday we were talking about organic conversion, and next week we will be talking about organic conversion part 2. Today is electrochemistry part 1, and the next week we are going to coming to electrochemistry part 2. From the next week onwards, we are going to present the total schedule of this. So, sare ke sare all topics will be covered when the chapter is started here, beta. Learn, hi. Learn, expert नाम दिया आपका, शुभ नाम नहीं लिखा यहाँ पर. I request my students, please write your actual name. Okay, spamming mat hoga. Okay, it is difficult. Shubham, yeah, good. Okay, funny, good. Right, so my question is not completed. Apart from batteries, how we are connected with electrochemistry? So if you complete this question, we can go into the topic. Good afternoon, beta. Sarah? Nice. Apart from the batteries, how we are connected with इलेक्ट्रोकेमिस्ट्री, जस्ट थोड़ा सा सोच के चार्ट में डालना. आई एम गोइंग टू रीड एवरीबॉडीज कॉमेंट देयर. हाँ नवीन, नो एक्सक्यूजेस. Come on. How we are connected with electrochemistry? Something you feel it and put in the chat box. इलेक्ट्रॉनिक एंड इलेक्ट्रिक बस, हाँ राइट, उसमें भी बैटरीज होगा, कार में भी बैटरी होगा. इलेक्ट्रिक कार, इलेक्ट्रिक बस, वी हैव बैटरीज. अपार्ट फ्रॉम बैटरी, इलेक्ट्रोकेमिस्ट्री में व्हाट इज द कनेक्शन वी हैव? I am just searching, anybody gives a small probe in this discussion. Lightning, okay, okay. उसमें केमिस्ट्री क्या, सिर्फ फिजिकल फिनोमेना है ना. सेल्स, उसमें भी बैटरी है ना, आरबीएस. ओके, और चलो, कैन आई गिव यू द क्लू? कैन आई गिव यू? हाँ, यस सारा, that's fantastic. So like emoji, come on, electroplating. Yes, it's an electroplating. Great. So we use iron, we have a car, we have a bike, it is painted. Okay, it is not only for show, it is for preventing rusting. So just let us go in details about this. Without a metal, human civilization would have not been this much. So metal is a part of our life. So metal has a tendency to rust or corrode itself. एक corrosion prevent करने के लिए हम paint इस्तेमाल करते हैं. So corrosion होता है क्या? The metal is converted into metal oxide. Iron is converted into iron oxide. It's an electrochemical phenomena. So electrochemistry हर chemical reaction में होगा. Not only rusting, हर chemical reaction में होगा. है ना बेटा? Yes, great. That's the response I wanted from you guys. So लगे रहो, chat box में लगे रहो. So that's why we are going to connect with each other, right? Now talking about, so chemistry is all part of studying chemical reaction. हर chemical reaction में you can see the loss of electron or gain of electron. So loss of electron or gain of electron is in form of oxidation and reduction, and these are studied under heading of electrochemistry. So coming to the importance of this chapter today, electrochemistry, in NEET examination in 2024, electrochemistry से सीधा 2 क्वेश्चन पूछा. Every year on an average 2 questions you can get it. So 2 questions means 8 marks. 8 marks out of 180 marks. So if you count 4 marks like that, each question carries 4 marks. If you add on 4 marks, you add 4 marks today, you add 4 more marks tomorrow's preparation, like that 4 more marks in the next Monday's preparation, like that you are going to amplify the score of your NEET 2025 in STEP UP program. That plan and that motivation you need to have, my dear students. समझ में रहे? Yes. Can electron pass through the empty metal? हाँ, why not? Empty metal का मतलब क्या? Metal is a metal. Metal का अंदर कुछ नहीं है, तो metal surface भी होता है ना. So electron pass through the metal. Hamad Ali, I am going to repeat. Actually, what I want to say here, this particular electrochemistry in 2024 examination, 2 questions were asked. When 2 questions were asked, it scored 8 marks. So if you plan for every chapter, at least थोड़ा सा prepare करने दो. So you can increase 4 marks now. 1 question you can do it confidently, which means that you increased 4 marks. Tomorrow you practice in such a way that 1 more question you are able to do, 4 more marks is increased. Like that, you prepare yourself in such a way that in a planned manner, every day you add up 4 mark in your score. सही बात है ना? So that your score is at the range of topper. 700 के ऊपर आना चाहिए. That is my advice. If you follow my lectures like this every day without any fail, I can assure you, you not only get a rank, you will be a topper beta. So future doctors, come on, electrochemistry चालू करेंगे. This particular chapter, I said it is from every year on an average 2 questions are being asked in NEET examination. Okay? हाँ. 10th grade before 9th. Okay. Thank you very much. Thank you for your gestures. Okay, come on. What are the subtopics that are included in this particular chapter? Galvanic cells, electrolysis, electrolytic conductance, and corrosion and batteries. 4 major concepts are there. In these 4 major concepts, I want to take each and every concept and elaborate as far as theory part is concerned and as far as concept part and formula part. In the next class, we are going to do applications of this. So let us continue here. Hello, 2025 RBS definitely on an average from the last 4-5 years I have seen 2 questions are asked for each year. 2025 also my projection is 2 questions from this particular chapter. If you just focus on it, I would get a question from here, a question from here, or question from here, like this. Major questions you are expected in these 2. And not only here, this connection of the electrochemical series is connected to D and F block and some other parts. Got it? And they also connect with thermodynamics also. So let us say, believe me, I am going to start today's class at 0 and I will take you to some depth of the concepts. Let's talk about galvanic cell. Before going for the galvanic cell, entire electrochemistry is about oxidation and reduction. चलो बेटा, what is oxidation reduction बोलना जल्दी. What is oxidation and reduction? Modern electronic concept. ऑक्सीडेशन रिडक्शन होता है क्या? फटाफट बोलना. आई एम जस्ट लुकिंग एट द चैट बॉक्स. रेस्पॉन्ड. हाँ. वो एडिशन इलेक्ट्रॉनिक का कॉन्सेप्ट, इलेक्ट्रॉन आने वाले के जाने वाले के प्रोसेस के बारे में बोलो. यस, गेन ऑफ ऑक्सीजन, रिमूवल ऑफ हाइड्रोजन. कम ऑन सारा. यस, ऑक्सीडेशन इज एन एडिशन ऑफ ऑक्सीजन. ओके. शिशु, ऑक्सीडेशन. Okay, Minu, oxidation, removal of hydrogen. I am asking in terms of transfer of electrons, gain of oxygen. So, response, come on, jaldi. Gain of electron, yes. Oxidation and reduction. So, you just correct yourself if anybody given a wrong thing here. Oxidation is loss of electron. Reduction means gain of electron, right? The entire chemistry follows this only. Some students is given in the reverse way, you just correct yourself. Okay? गलती कर सकते हैं लेकिन correction भी करना है. हाँ, RBS, you are correct. Oxidation, let us see. Sodium metal loses electron. This is called oxidation. Sodium ion gain the electron, gives rise sodium metal. This is reduction. And one more important point. That's good. Pawan, good. So the one which is oxidizing agent and a reductant. oxidant or oxidizing agent, reductant और reducing agent. Oxidant होता है the species वो खुद reduce कर रहे हैं, so it reduces itself. Reductant होता है और reducing agent होता है the species which oxidizes itself. ठीक है, come on. So not only the electrochemistry but entire chemistry follows this fundamental, and we are going to see more about this oxidation and reduction in electrochemistry dear. So let us talk about galvanic cell. This is your galvanic cell or a Daniell cell. So what is a galvanic cell and a Daniell cell? It is a kind of electrochemical cell where spontaneous oxidation and reduction takes place. That's what, before I want to say the definition of a galvanic cell, I want to say oxidation and reduction. ठीक है? Yes, beryllium 2 electron, beryllium 2 plus 2 electron, beryllium jagan. Okay, that helps in the oxidation reduction. Yes. Okay, come on. Let's talk about the galvanic cell. Galvanic cell is an electrochemical cell. जो cell इस्तेमाल करता है electrochemistry में, that is called electrochemical cell. There a spontaneous oxidation and reduction takes place. That is called, so that movement of the electron takes place. That cell is called electrochemical cell of a galvanic cell. And what are the reactions that takes place in the galvanic cell? This is the first concept actually in this. So you have taken a zinc rod here. This is your zinc rod. You have taken zinc rod and placed it in the solution of zinc sulfate, and you have taken a copper rod and placed it in copper sulfate. So what happens when they are connected by using external voltmeter or external detector, and they are connected with a salt bridge. Now I am going to talk about salt bridge in next coming slides. This is the experimental setup of the galvanic cell. This is the first electrochemical reaction we are going to observe. You want to ask something, you can ask. So that help in oxidation reduction process definitely बेटा. और क्या? और कुछ बोल रहे हैं? Okay. So what are the reactions that takes place? Zinc is in the solid state. The reactions that takes place, zinc, a metal which is in the solid state, है ना? It lose electron. Why it lose also I'll tell you. So that zinc is converted into zinc 2 plus. Zinc 2 plus in the aqueous. So zinc is dissolving. Zinc is dissolving in the solution. So this is a loss of electron process. We can say it is an oxidation process. This process is called oxidation process. कुछ doubt है क्या उसमें? So hundreds of students are attending. कोई चार्ट ना इस्तेमाल कर रहे हैं? कुछ भी ना कुछ बोलना है यार. Come on. And the electron that is lost by this zinc, carefully you see, the electron is moving through the external circuit and reaching to the copper. So that copper sulfate contain copper 2 plus ions. These copper 2 plus ions, these electrons are captured by the copper 2 plus ions. Copper 2 plus ions takes from the aqueous state, takes electrons and become copper, which is in the solid state. So as a result of this, copper metal is being deposited on the surface of the copper. समझे? So the mass of the copper is increased during this process. At the same time, mass of the zinc is gradually decreasing during the mass, during this process. So I just want to say mass of zinc decreases, this is the observation, mass of copper increases. So this is a reduction process and this is an oxidation process. फिलहाल कुछ प्रॉब्लम है तो बोलो, come on, chat box engage करना है बेटा. Yes, Pavan Kumar, that was the reduction reaction. Jagan, it's a good question. Why it should lose electron? Why it should lose electron? That's a question. Anybody can give that if you know that. If you know that. No, you don't know. Okay. मैं हूं ना, I'll tell you. So this is a cracky points, my dear students. The galvanic cell, if you open your book also, you can understand. I'm explaining, that's well and good. But there are certain doubts where only teacher can answer your questions, right? इलेक्ट्रॉन ग्राउंड स्टेट, कुछ ग्राउंड स्टेट है नहीं उसमें, सिर्फ रिएक्शन मिक्सचर में है ना. पवन, राइट? जयंत, यू टॉकिंग अबाउट ऑक्टेट रूल, दोनों का ऑक्टेट बराबर है. Great, it's a discussion, great discussion. अरे बेटा, if you are able to answer this question, electrochemistry, you can excel. If you don't know the answer, not an issue. But if you could able to answer, you are in the track. है ना? Octet rule, okay. Hamad Ali. So, students were asking why zinc should lose electron. ये जिंक इलेक्ट्रॉन क्यों दे रहे हैं, कॉपर इलेक्ट्रॉन क्यों ले रहे हैं? उल्टा नहीं चल रहे. कॉपर दे सकते हैं ना, जिंक ले सकते हैं. दैट इज नॉट हैपनिंग इन द नेचर, है ना बेटा? पवन फाइन बेटा. जिंक इज स्टेबल, कॉपर भी स्टेबल है ना सारा. जिंक इज स्टेबल, कॉपर इज स्टेबल. हाँ, मैं आंसर बोल रहा हूं आपको. इलेक्ट्रोलिसिस, हाँ, यहाँ पर इलेक्ट्रोलिसिस नहीं होगा. रिएक्टिविटी सीरीज, सम, यू आर कनेक्टिंग. हमद अली, यू आर कनेक्टेड देयर ओनली. पवन, मैं आ रहा हूं उस पर, कोई प्रॉब्लम नहीं बेटा. सो अगर एक मेटल का इलेक्ट्रोलाइट में डालें तो इट एक्सपीरियंस सम पोटेंशियल, दैट इज कॉल्ड इलेक्ट्रोड पोटेंशियल. कोई भी मेटल है, इसका इलेक्ट्रोड में रखेंगे तो मेटल एंड इलेक्ट्रोलाइट के बीच में कुछ इलेक्ट्रॉनिक गैप होते हैं, दैट इज कॉल्ड इलेक्ट्रोड पोटेंशियल. ये इलेक्ट्रोड पोटेंशियल का कुछ वैल्यू होगा. ये वैल्यू रिलेटिवली दोनों कंपेयर करेंगे तो जिंक का इलेक्ट्रॉन देने का संभावना ज्यादा होता है, सब कॉपर का इलेक्ट्रॉन लेने का संभावना ज्यादा होता है. इसी का कारण जिंक से कॉपर का इलेक्ट्रॉन आ रहा है, उल्टा नहीं चल रहे हैं. समझ में रहे क्या? या सारा, यू आर गिवन द explanation according to electrochemical series. The answer is given by Sara is good. पवन, समझ में आ रहा है क्या? चलो, come on, like फायर इमोजी देना. आगे बढ़ेंगे. Yes, great. So these are the reactions. These are the reactions. Now, if you see this, what is the direction of electron flow and the direction of current? When zinc loses electron and becomes zinc 2+, the electrons are moving from zinc and going to copper, and it is coming like this to deposit copper. So electrons are flowing through the external circuit. Electrons are going in this way. According to physics convention, current is flowing in the opposite way. These directions are very important to answer theoretical questions in the NEET examinations, children. Right? Current flow in the opposite to electron flow, perfect. Perfect. So, negative to positive. So, here anode is called a negative, cathode is called positive. I want to tell you very important point, जहाँ पर नेगेटिव होगा ये एनोड है, जहाँ पर पॉजिटिव होगा कैथोड है, इलेक्ट्रोलाइसिस में ये उल्टा है, वो गलत बात है. सो दैट इज साइन कन्वर्शन इज सही है, लेकिन सोचना गलत बात है. एनोड कैथोड कैसे नेम करेंगे? जिस इलेक्ट्रोड पर ऑक्सीडेशन होता है with respect of the charge, that is anode. Yes, and it is opposite beta. And जिस इलेक्ट्रोड है कैथोड बोल सकते हैं अगर आप रिडक्शन होगा तो. The electrode is called anode where oxidation takes place. The electrode is called cathode where reduction takes place. And the flow of electron from anode to cathode through the external circuit, current is from cathode to anode through internal circuit. Got it, beta? Very good. Nice. Now what else? What is the IUPAC representation of this? IUPAC हमेशा जानते रहते हैं आपको. What is IUPAC? International Union of Pure and Applied Chemistry. IUPAC not only says writing a naming of organic compounds, but also naming of inorganic compounds, but also it tells you the rules that we have to follow in chemistry. है ना? So what is IUPAC representation? Basic standard notation आपको बोलना चाहता हूँ मैं. When these chemical reactions are there, let us see what are the chemical reactions that happens here. Look at here. Zinc loses 2 electron, becomes zinc 2 plus. ये ऑक्सीडेशन है. जहां पर ऑक्सीडेशन होता है ये एनोड है. आपका कैथोड क्या होगा? कॉपर 2 प्लस takes 2 electron and become copper. ये रिडक्शन होगा. ओवरऑल रिएक्शन क्या होगा? जिंक कॉपर 2 प्लस and zinc 2 plus and copper. है ना बेटा? Now IUPAC रूल्स का हिसाब से आपका गैल्वानिक सेल रिप्रेजेंटेशन होगा. LHS में अब एनोड लिखना है, RHS में आपका कैथोड लिखना है. And anode and cathode are separated by using a salt bridge. Salt bridge is represented by using 2 vertical lines. Clear बेटा? हाँ आरहान, हाँ बोलो. Now what is LHS anode है? So उसमें zinc is converted into zinc 2 plus. And zinc is electrode, and zinc 2 plus is ion. These are separated by a metal liquid interface. समझ में आ रहे? हाँ, क्वेश्चंस भी, ट्रिक भी बोल जाएगा. फराज ट्रिक्स भी बोलना है. And this metal interface is separated by a vertical line. Anode oxidation takes place. Arhan, you said correct. यहाँ पर copper 2 plus is converted into copper and this is a metal interface. Copper 2 plus is converted into copper. ये दोनों, ये एनोडिक कंपार्टमेंट है, ये कैथोडिक कंपार्टमेंट है. दोनों ये सॉल्ट ब्रिज इस्तेमाल करके सेपरेट करना है. सो दिस इज योर IUPAC रिप्रेजेंटेशन. It is given like this also. समझ में आ रही क्या? हाँ, क्या ये फुल ईयर बैच है क्या? पवन, ये फुल ईयर बैच का है. पूरा सारा के सारा सिलेबस आपको खत्म होगा. Great. Okay, come on. In this, what is this? This is called salt bridge. आगे स्लाइड में आपको salt bridge explain करना है. Any doubt here so far? Salt bridge prevents the liquid junction potential. Arhan Das, very good. Good. So salt bridge, first of all, what is a salt bridge? Let us see. In this U-shaped glass tube is called salt bridge. ये ब्रिज है. ये कंपार्टमेंट अलग कर दिया ना. ये दोनों कंपार्टमेंट कनेक्ट करने के एक चीज चाहिए, दैट इज ए सॉल्ट ब्रिज, ए कंडक्टिंग ब्रिज. You can keep anything that connects electrically between, but ionic neutrality should be maintained. So a salt bridge is U-shaped inverted tube. A tube में क्या fill करते हैं? This is filled with potassium chloride or any salt. And if you fill aqueous potassium chloride, what will happen when you invert it? उल्टा करेंगे तो गिर जाएगा ना. Liquid can't be stay. So that has to be made into a paste and a jelly-like form. Jelly chocolate खा देंगे आप. It is not in a solid state or not in a liquid state. It is jelly state. Like that, we mix agar. We mix agar powder to make it jelly, so that it conduct electricity. What happens during this? This is a salt bridge. इसका first role क्या? It completes the circuit. If it is not here, what happen? Electron circuit is not completed. First it has to complete its circuit now. And when zinc is dissolving here and copper is depositing here, पॉजिटिव चार्ज यहां पर बढ़ रहा है, नेगेटिव चार्ज पूरा यहां से यहां तक आ रहा है ना. सो नेगेटिव चार्ज यहां पर बढ़ रहा है, पॉजिटिव चार्ज यहां पर बढ़ रहा है. सो दैट we are accumulating the charges in different containers, which is not correct. It has to maintain electrical neutrality. To maintain electrical neutrality, what will happen in the KCl, K plus and Cl minus होगा, Cl minus यहाँ पर घुस जाएगा, and you can see the K plus will come here. So it maintains electrical neutrality. समझ में? Thickness of anode or decrease. हाँ, I already given Arhan. Mass of anode decreases, mass of cathode increases. Arhan, I already given. Prevents backflow of electron. Yes, of course you can say that it maintain electrical neutrality. Also, it prevents the accumulation of the charges. You can say it is a liquid electrode potential junction. Charge accumulation. Okay, मेरा सवाल है कि वेरी गुड क्वेश्चन आई जस्ट वांट टू आस्क. उसमें KCl इस्तेमाल किया और क्या साल्ट इस्तेमाल किया जाएगा? कौन सा साल्ट इस्तेमाल कर सकते हैं हम? इट्स वेरी सिंपल. वी हैव टू यूज a salt where the cation and anion, ionic mobility of cation, you can say ionic mobility of cation, ionic mobility of anion, दोनों बराबर होना चाहिए. You can't use calcium fluoride. So fluoride का ionic mobility ज़्यादा होगा, calcium का कम होगा. सो इफ इट्स एन एक्वियस फ्लोराइड का कम होगा, कैल्शियम का ज़्यादा होगा, है ना. सो ionic salt, ionic salts are polar, okay, polar ionic salts. So every ionic salt is polar only, है ना, right. So I would say a ionic salt we have to use where ionic mobility of cation should equal to anion. Now my dear students, I just want to ask you a quick question. Now this particular galvanic cell is showing, let us say 1.1 volt. अचानक से ये salt bridge निकाल दिया मैं. I removed salt bridge. What you will observe? Can we do G questions for NEET special videos? that you can do, but every question you need not have to. हर क्वेश्चंस करने की जरूरत नहीं बेटा. some क्वेश्चंस करने चाहिए, है ना. पवन, ओके, आई कैन अंडरस्टैंड. ओके, नीट सीरीज में जितना हिंदी भी होगा, इंग्लिश भी होगा, इंग्लिश भी होगा, है ना, कोई प्रॉब्लम नहीं. पेश में आहिस्ता आहिस्ता आपको आदत पड़ेंगे. ओके, कम ऑन, चलो. पवन, टेक इट एज ए नोट. ओके, डोंट फील बैड, कम ऑन. यस. So functions of salt bridge, I already given the functions of salt bridge. It completes the electric circle. हम मिक्स करके बोल रहे हैं, that is not a concern here. चलो. Maintain electrochemical neutrality. It prevent liquid junction potential. Has you have given my answer for my question. When I remove the salt bridge, you said 0 volt दिखेंगे क्योंकि circuit break हो रहा है. It do not complete the circuit ना, it complete the circuit. अगर circuit incomplete होगा तो you don't see any deflection here. Got it? Perfect answer गया रेहान. Very good, nice. इस तरह the voltage is going to be 0. Great, great. Okay, by the way, the battery that we use in the remote control, what is the voltage? Can you check and tell me? If you have an idea from your mind, you tell me. Don't open remote controls. No deflection, Jagan. No deflection means 0 volt only. आपका आंसर मंजूर है, ठीक है. So the battery we use, the electrochemical battery we use in the remote control, it is 1.5 volt. Sara, correct. 2 or 6. 2 volt batteries are not there, 6 volt batteries are there. Okay, in the special cases 6 volt batteries are there. 1.5 ही इस्तेमाल करते हैं, ठीक है. come on. Electrode potential. What is the electrode potential? Now we are going into the deep. मेरा जो पहला क्वेश्चन है ना, you only asked why zinc is given electron, why copper is taken electron. So that can be answered by the electrode potential. We use 230 volts in our house, that is AC, not DC. ये सरकारी का इलेक्ट्रिसिटी आते हैं ना, ये 230 volts, that is alternative current, not direct current. So DC and AC, DC power we use from batteries or inverters, but AC is directly from transmission, right? हाँ, 0.5 कहाँ देंगे मैं कहीं नहीं देगा 0.5. वो डिस्चार्ज होने वाला क्या बैटरी आते 0.5 ना. डिस्चार्ज होने के वक्त में 0.5 तक चलेगा. So you can just type and you can interact with chart. You need not have to retract the messages and all, right? Come on. So when a metal, you see, this is a metal, let us say a copper metal or a zinc metal, is dipped in zinc sulfate, उसमें zinc 2+ होगा. So it experiences when a metal and a metal ion, when they are in the contact, ये दोनों का इंटरफेस में, ये सॉलिड है ना, ये लिक्विड है ना, ये सॉलिड का लिक्विड का जो इंटरफेस होता है, वो इंटरफेस में कुछ पोटेंशियल दिख जाएगा. इट फील इट एक्सपीरियंसेस सम पोटेंशियल. that potential is called electrode potential. वो इलेक्ट्रोड पोटेंशियल आप कैलकुलेट करना चाहते हो स्टैंडर्ड स्टेट में. सो 298 केल्विन का टेम्परेचर ले लो एंड 1 atm का प्रेशर ले लो. दैट इज कॉल्ड स्टैंडर्ड इलेक्ट्रोड पोटेंशियल. ओके, दैट स्टैंडर्ड इलेक्ट्रोड पोटेंशियल, द वैल्यू, it can be taken in either ways. It can be taken in either ways. So zinc is converted into zinc 2 plus by the loss of electron. ये process का oxidation हो रहा है. So that is called zinc 2 plus zinc and zinc 2 plus. This is what you call it electrode potential for oxidation process. This is called standard oxidation potential. Got it? इसका value you please don't memorize it. I am a teacher, I memorize it and I'll give it here. In the examination that will be given in the question paper. हाँ, Arhan, can I crack NEET if I start now, sir? प्लीज टेल मी. डेफिनेटली इफ आज करेंगे तो जो आज करना काम अभी शुरू करो, पक्का हो जाएगा. अरहान, डेफिनेटली इट कैन बी डन. नॉट ओनली यू कैन क्रैक बट आल्सो यू कैन बी ए टॉपर एज वेल. फॉर एंटायर क्लास आई एम टेलिंग दिस इज ट्रू फैक्ट, बिलीव मी. Yesterday also I was addressing the same. In the last 2023, one student, a group of students, they are just 320, 340. The group of students, year long they have taken a drop and written 2024. They are getting 700, 705, 710, like that marks they are getting. The power of drop, the effort of drop you have given, it gives a lot of support in your future, dear. Now you feel that you are dropped for this year. In the future you will become a doctor. Name doctor beyond your name. Arhan, fine, accept it. All students give your acceptance by thumbs up. That indicates your belief system. That indicates your belief system. Do you believe in yourself? Come on. Right? Yes, Pavan, great. एक ही thumbs up है ना. और so this value is, I know it is minus 0.76 volts. Right? Okay. शेषु क्या रिमूव करना है? Hamad Ali, that's good, 3 thumbs ups. Great. So if you see the ulta process, अगर प्रोसेस उल्टा करेंगे तो क्या होगा? Zinc 2 plus takes an electron and gives rise. Zinc a process होगा, reduction है ना, acceptance of an electron, reduction है ना. So that this is called, this is indicated as copper, sorry, zinc 2 plus and zinc, and this is electrode potential for reduction process, so that it is called standard reduction potential. That's correct. SRP, इसका वैल्यू होगा पॉजिटिव 0.76 वोल्ट्स. सो क्या ऑब्जर्व कर सकते हैं आप? You can observe many things over here. This value is a negative, this value is a positive. This value is microphone. Can you hear me all? Children, can you hear me all? Give comment over here, because it's shown microphone is having some issue. just a minute, give me a minute. Yes, you can see the width. Just a minute, beta. Keep on. Is that fine? Okay. So, what is the observation you can give? That's good. Okay, you want quiz? Yes, you are audible. Okay. Now you see the SRP value, SOP value दोनों का मैग्नीट्यूड सेम होगा, मैग्नीट्यूड वैल्यू सेम होगा, लेकिन साइन उल्टा होगा. So SOP value and SRP value, just only the sign is different. One more important point, it doesn't mean that SOP value हमेशा नेगेटिव है, SRP value हमेशा पॉजिटिव है, उल्टा भी हो सकता है ना. If you consider copper, E0 value of copper 2 plus and copper, that is plus 0.34 volts, this is SRP value से है. अगर E0 value of copper and copper 2 plus SOP value से, that is minus 0.34 volts. You please don't memorize these values, it will be given in the examination. Fine? That's good. Great. Now let us talk about, आगे बढ़ेंगे करो. So what do we understand based on SOP value and SRP value? This is a key point I just want to tell you. If you understand this, you can handle majority of the chemistry textbook. Not only electrochemistry but also D and F block में है. Okay? Value कैसे calculate करना अहमद अली? Yes, I will say. This value I said it is minus 0.76. That's the absolute value. जब zinc is dipped in zinc 2 plus, it experience 0.76 value. इसको पता, हमको कैसे पता चलेगा? When copper is dipped in copper sulfate, it experiences plus 0.34 volts. It knows, but how do we know? We have to calculate these values by using a reference value. So these are called absolute value. Absolute value of electrochemical cell, electrode potential, you cannot calculate. Rather, you can calculate by using standard hydrogen electrode. This is called normal hydrogen electrode or standard hydrogen electrode. The standard hydrogen electrode is constructed in such a way that platinum metal is used as an electrode and it is enclosed with hydrogen gas and immersed in हाइड्रोजन क्लोराइड सॉल्यूशन ताकि आपका मिलेगा H प्लस आयन कॉन्सेंट्रेशन 1 मोलर. हाइड्रोजन गैस प्रेशर में दे दिया, देन यू विल गेट इट प्रेशर इज 1 atm. Pressure is going to be 1 atm. The temperature is maintained 25 degree centigrade. ये कंडीशन में 280 25 degree centigrade means 298 Kelvin. ये कंडीशन में this hydrogen electrode experiences some potential because this is a metal and this is the ion. and this is given as H plus electron gives rise hydrogen. यहाँ पर H प्लस है ना, H प्लस यहाँ पर हाइड्रोजन है ना, these two are maintaining an equilibrium, so that at equilibrium the potential experienced is considered to be 0.0 volt. I said you cannot calculate absolute value, but by taking this reference you can calculate the difference between these two. So what happened? This is your galvanic cell. In this galvanic cell, this is a zinc and this is a copper. ये दोनों का इलेक्ट्रोड पोटेंशियल का डिफरेंस 1.1 आप मेजर कर सकते हैं, डिफरेंस मेजर कर सकते हैं. इसका वैल्यू यू कैनॉट कैलकुलेट, इसका वैल्यू यू कैनॉट कैलकुलेट. लाइक दोनों का अंतर जो है ना 1.1 वोल्ट. By taking this as a zero and it is connected with zinc, जिंक एंड हाइड्रोजन का अंतर आप निकाल सकते हैं. बाई कंसिडरिंग इसका वैल्यू 0 होगा, आपको जो भी वैल्यू यहां पर देखेंगे इट इज 0.76 it is shown. You understand? That is how you calculate it. Are you getting or not? Why it is dipped with platinum black? Yes, of course. That's good. Is SOP values are always negative? नहीं. SOP value negative होगा, किस चीज को negative होता है और किस चीज को positive होगा. It can be like this or like this. समझ में आ रही है? हमद अली, this is for you explanation. संतुष्ट है आप? Great, very good. Now if you consider these electrochemical values, electrochemical potential values, what you will understand? That's good. So as standard oxidation potential, एक खतरनाक स्लाइड है, स्टैंडर्ड ऑक्सीडेशन पोटेंशियल वैल्यू बढ़ जाएंगे तो ए टेंडेंसी ऑफ खुद ऑक्सीडाइज करने का टेंडेंसी ज्यादा होता है ना. द वन विच ऑक्सीडाइजेस इटसेल्फ इज गोइंग टू बी ए ग्रेट रिड्यूसिंग एजेंट. सो as SOP value increases, tendency to get oxidized nature also increased and reducing power increases. That is simplest version. And as SRP value increases, tendency to get reduction also increases, oxidizing power increases. है ना? Now let us take the values, SRP values. जिंक का -0.76, कॉपर का I am taking an example and I am explaining you. It doesn't mean that I ask you to memorize these values, है ना. प्लस 0.34 volts. किसका SRP वैल्यू ज्यादा है? मैथमेटिकली किसका वैल्यू ज्यादा है? चार्ट बॉक्स में तो लो. मैथमेटिकली दोनों में किस वैल्यू ज्यादा है? कॉपर का वैल्यू ज्यादा है. सो कॉपर का वैल्यू ज्यादा है. सो एसआरपी वैल्यू किसका ज्यादा है उस रिडक्शन ज्यादा होगा. दैट इज द रीजन वाई कॉपर रिड्यूस करने का संभावना ज्यादा होता है. इसी का कारण ये रिएक्शन होगा. आर यू गेटिंग और नॉट? ये सेम फिनोमेना उल्टा करके जिंक का इस्तेमाल करो. जिंक का मैथमेटिकल वैल्यू ऑफ एसआरपी वैल्यू कम है. सो एसआरपी वैल्यू कम ही होगा तो टेंडेंसी ऑफ रिडक्शन कम होगा. टेंडेंसी ऑफ रिडक्शन कम होगा का मतलब टेंडेंसी ऑफ ऑक्सीडेशन ज्यादा होगा. सो दैट मान लो जिंक is going to lose electrons and gives rise zinc. ये oxidation होगा. The same reactions that are happening in your galvanic cell. Jayant, reducing power है, the tendency to make others to reduce, ये खुद oxidize होना है. ठीक है मैडम? Great. Fantastic, fantastic. That's why I started the entire discussion right from the slide 1 beginning. What is oxidation? What is reduction? Usually students, what they do, when they start, they directly go into the main course. But in electrochemistry, it is required to understand oxidation होता है क्या, oxidizing agent होता है क्या, reduction होता है क्या, reducing agent होता है क्या. So relative tendency of oxidation है, reduction है, दोनों के देखना है. ठीक है बेटा? Clear? Any doubt? Come on. Come on. Now let us say आगे बढ़ेंगे थोड़ा. So this slide, everybody take a snapshot of it. This helps you a lot. This helps you a lot. Come on. So maximum potential the EMF. What is EMF? Electron motive force. Electron motive force. Now this is zinc and zinc sulfate, है ना, right. And this is a copper and a copper sulfate. And these two are connected by using voltmeter. अभी बोलो वोल्टमीटर में वोल्टेज कितना दिखेगा? अभी वोल्टमीटर में वोल्टेज कितना दिखेगा भाई इसी वक्त में? Expecting answers. Expecting answers. Go to the previous slides. 1.1. Jagan, hold on. ये ख्याल में रख के 1.1 बोल रहे हैं सभी. ओके. ओके. Raj Srivatsav. Okay, you are my previous student. You are my previous student. You are in IIT Delhi now. Okay, anyways. So ये ख्याल में रख के आप 1.1 बोल रहे हैं, लेकिन you can see, yes, यहाँ पर सिर्फ 0 देखेंगे इसी वक्त में, क्योंकि ये सर्क्यूट कंप्लीट हुआ नहीं. 0 भी दिखते हैं. अभी में साल्ट ब्रिज रखने तो रिएक्शन चालू होगा. शुरू में 1.1 दिखेगा. एज टाइम गोस ऑन 1.0, 0.9, 0.8 इक्विलिब्रियम जब आएंगे ना 0 देखेंगे. यस, दैट्स गुड. अगर साल्ट ब्रिज होगा तो वोल्टेज दिखाई देते हैं आपको. अगर साल्ट ब्रिज नहीं होगा तो सर्क्यूट कंप्लीट नहीं होगा. राइट. टॉकिंग अबाउट, सो लेट अस से जस्ट वी स्विच ऑन. सो इनिशियल है ना, अभी तो तुरंत मैक्सिमम पोटेंशियल डिफरेंस बिटवीन टू इलेक्ट्रोड. ये इलेक्ट्रोड का पोटेंशियल 0.76 माइनस SRP, ये वाला प्लस 0.34 वोल्ट्स शुरू में. when they are connected, the expected, when the reaction are not started, when the reactions that takes place, how much potential difference between these two when the cell is not in use, that is called maximum potential difference between two electrodes when cell is not in use, that is called EMF. At standard स्टेट में EMF इज इक्वल टू ई नॉट ऑफ कैथोड, ये कैथोड है ना, ये एनोड है ना, कैथोड ई नॉट माइनस एनोड ई नॉट. सो ई नॉट में SRP निकालना, SRP पकड़ना और SOP पकड़ना. SOP or SRP. Mind it, dear students, always you take SRP if it is not mentioned. SRP ख्याल में रखो. कभी कभी SOP देते क्वेश्चन में, लेकिन ये फॉर्मूला इस्तेमाल करने के वक्त में SRP में कन्वर्ट करो. कैसे कन्वर्ट करते SOP SRP? सिर्फ साइन बदलना, ठीक है, सिर्फ साइन बदलना. ओके, EMF और E सेल इज इक्वल टू E नॉट सेल इज इक्वल टू E नॉट ऑफ कैथोड ऑफ SRP प्लस 0.34 minus of 0.76. If you calculate so, that is going to be plus 1.1 voltage आएगा. That is the electrode EMF that we calculate for our galvanic cell or Daniel cell. Are you getting or not? Children, you are still calculating? Keep chat box always engaged. Say, fine, you understand? Fine, you understand? Come on. Make it this interaction. It's a live session, children. Come on. That's good. That's good. Ha 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 ha. Great. Come on. Take a snapshot of this. बिकॉज दिस एक खतरनाक फॉर्मूला है, एक खतरनाक फॉर्मूला कहीं भी इस्तेमाल करो इलेक्ट्रोकेमिस्ट्री में. टेक ए स्नैपशॉट इट. 1 2 3. दैट्स गुड. नाउ Nernst equation. What is this Nernst equation? This is the standard state. Standard state means when the concentration of this zinc sulfate is in 1 molar, copper sulfate concentration is 1 molar. तभी आपका 1.1 वोल्ट दिखेगा. So during experiment what happens, if I dissolve copper sulfate solution separately, concentrated copper sulfate separately, and pour in this cabin, pour in this vessel, then what happen, ये value बढ़ जाएगा. So I mean to say electrode potential value is dependent on concentration. It do not depend on the size of the electrode. It do not depend on the size of electrode. ये पतला वाला जिंक इस्तेमाल करो और you can use a rod or a plate, कुछ फर्क नहीं पड़ता है. लेकिन एक concentration डिपेंड करते हैं, प्रेशर डिपेंड में और टेम्परेचर में भी होगा. So Nernst equation is an equation which tells us the concentration dependent. ये standard state में नहीं, अलग concentration में अलग states में. So that is given as a Nernst equation. Nernst equation means E cell means it is non-standard condition, non-standard concentrations. It is given as E naught cell minus 2.303 RT by NF log QC. What is this QC? Remember ionic equilibrium and chemical equilibrium, children? QC होता है क्या? If you remember, if A moles of A, B moles of B are in reaction to give rise C moles of C and D moles of D. How many of you remember reaction quotient QC. How many of you remember? Yes, it is not equilibrium constant, Arhan. Equilibrium constant अलग ही है. So QC is, अब जो सोच रहे हैं ना वही है, लेकिन सिचुएशन अलग है. That is C moles of C to the power C dot molarity of D to the power D and molarity of A to the power A, molarity of B to the power B. है ना? This is called reaction quotient. हाँ, everybody says it. कैसे लिख दिया सर आप? ये कैसी QC अलग चीज है, देखने का सेम बराबर देखते हैं. QC is equal to KC जब कंडीशन इक्विलिब्रियम स्टेट में है. अगर QC KC is not equal, the reaction system is not at equilibrium. QC and KC are same लिखने का, लेकिन कंडीशन निकालने का वक्त अलग है. So that is the QC. So 2 point E naught cell. What is E naught cell? हर चीज को देखना है. पर E cell, here E cell is equal to E naught cell minus 2.303 RT upon NF log QC. Again I have written the same. What is this N? What is this F? When you see this, हमारा zinc Daniel cell की equation, zinc gives us zinc 2 plus 2 electrons, copper 2 plus 2 electrons and gives copper. If we add these equations now, carefully you see, my dear children, in this oxidation process में 2 electron release किया, ये reduction process में 2 electrons accept किया. So total oxidation process में 2 electrons निकाल गया, 2 electrons आ रहे हैं. So that the entire redox equation is given as zinc plus copper 2 plus gives rise to copper and zinc 2 plus. ये redox process में आपका 2 electron involve किया. So that is called N value. That is called N value. N is the number of electrons. That is called number of electrons. Then what about F? F value is Faraday. 1 Faraday is equal to 96,500 coulombs. That's a constant value. 1 Faraday is equal to charge carried by 1 mole of electron. Ishita, outstanding answer. Arhan, you are saying temperature in Kelvin. Here temperature in Kelvin. Not only here, कहीं भी total chemistry में temperature आप इस्तेमाल करना चाहता हूँ, Kelvin में इस्तेमाल करना. Without Kelvin temperature, no formula is there in the chemistry. It is a thumb rule. ठीक है? Now, temperature is standard state में it is 298 Kelvin. है ना? R value 8.314 joule Kelvin inverse mole inverse. If you put this value, this value, this value, आपका मिलेगा and 2.303 से multiply करो, आपका मिलेगा E cell is equal to E naught cell minus 0.0591 by, सिर्फ n is a variable, अलग reactions को अलग अलग n value होगा. Okay, log to the base 10 of QC. QC means you can use the QC over here. I will tell you how to write QC for this also. Okay, so now what is E naught value? Thoda sa, it is a standard value. It is 1.1 for our Daniell cell. That is for not our Daniell cell, for any other cell you can calculate from E naught cell is equal to E naught of cathode minus E naught of anode. समझे बेटा? Got it? So by using this only, you have so many formulas in the electrochemistry, no? Yes, we have, but these so many formulas, only basic formula you can take it and you can just go ahead with आगे क्या करना, ये कैसा इस्तेमाल करना, ठीक है? Right. Take a snapshot of this Nernst equation. Nernst equation is used to calculate non-standard condition में electrode potential of a cell. Non-standard conditions में. Any doubts? Is a Faraday's constant. F is a Faraday's constant. N is the number of electrons involved in it. R is a universal constant. Okay. You understood the difference between QC and KC? Now, concentration cells. What is this concentration cells? The previous one, you see, yes, this is a Daniell cell, उसमें electrode, electrolyte अलग है, लेकिन यहाँ पर same electrode copper is taken in copper sulfate, again copper is taken in copper sulfate, and these two are connected by using a salt bridge, है ना? So concentration cells are these cells, Daniell cells or electrochemical cells, which has the same electrode and electrolyte with different concentrations. यहाँ पर concentration C1 होगा, यहाँ पर concentration C2 होगा. Got it? So let it be, it is 1 molar and here it is 2 molar. If it is 1 molar, इसका electrode potential अलग होगा. If it is 2 molar, यहाँ पर electrode potential और अलग होगा. So different electrode potentials are connected by a voltmeter. Potential difference देखेगा आपको. When you are connected these two, so condition whenever this E naught हमेशा constant है ना, इसका भी E naught का मतलब क्या? Standard state में. In this standard state, concentration cell, whenever you use concentration cell, this is the mandatory condition bus. This is the mandatory condition. And we are coming to the end of the session. For today only we are talking about galvanic cell. We will be having electrochemistry part 2 also. You just continue here. Yes. Now let's see how many types of electrochemical cells are there. Concentration electrochemical cells. 2 types of concentration electrochemical are there. Concentration cells, दो तरीका है कि electrolytic electrochemical cell, concentration electrochemical cell. दूसरा आता है आपको electrode concentration cells. So electrolytic का आपका liquid electrode जो है ना, इसका concentration अलग होना चाहिए. If it is electrode वाला है ना, if it is somewhere some gases are released, you can have P2 and P1 if gases are there. In this example, gases are not there. So C1 is concentration, P1 is pressure, P2 is pressure, C2 is concentration. So we have to take different pressures, different concentrations. That are pressure वाला एक है and concentration वाला और एक है. So इसका क्या होगा? As I said, we can see E cell is equal to E naught cell minus 0.0591 by N. पिछला वाला, so how do you write? It is cathode by E cell is equal to E naught cell minus 0.0591 by N. ये एनोड था, ये कैथोड है. So you can say log QC, concentration of anode, concentration of cathode. So let's see here, at anode you have C1 and cathode you have C2. Now in this way, anode you have C1 and cathode you have C2. Are you getting or not? Simple version I am telling you. As this value you have to take as 0, you can say E cell is equal to plus 0.0591 log C2 by C1. This is the formula for this. Great beta, right? RBS. If this is the case, E cell is equal to again plus 0.0591 0.591 okay by n log P1 by P2. In this case थोड़ा सा लॉजिक का हिसाब से अगर log C2 by C1 greater than 0 होगा तो E cell is going to be greater than 0. अगर greater than 0 होगा तो cell works. If the E cell is 0, the cell is at equilibrium. If E cell is positive, the cell is going to get some voltage. If E cell is negative, reaction आगे बढ़ना मुश्किल है. Are you getting or not beta? Now, today we learned about introduction about electrochemistry, oxidation and reduction, construction of a galvanic cell, and salt bridge, function of salt bridge, and IUPAC representation of a galvanic cell, and Nernst equation, single electrode potential and oxidation potential and reduction potential, दोनों का क्या फर्क पड़ता है, कैसे convert करना. Okay, later on we moved into Nernst equation, then we come across with concentration cell, थोड़ा सा append करना NCERT से. So I request my students, as a homework, everybody take a NCERT textbook or NEET textbooks. You find Nernst equation questions and IUPAC representation of galvanic cell questions and start solving. And the rest of the part of the electrochemistry we will be seeing in the next class, and electrochemistry part 2 and everything we are going to discuss. PDF, everybody, children, everybody join in Telegram group where we are going to provide you the PDF of all material and updates of next coming class, क्या है, कौन सा topic क्या है क्या. Okay, hope you all enjoyed my class. Okay, please share this session with your friends and like मारो, subscribe करो, NEET 2025 channel को subscribe करो. Okay, God bless you all. फिर मिलेंगे आगे क्लास में. Thank you. See you. Bye bye.